This problem again involves a three-dimensional figure, so it's important that we understand that we need to be able to have flat surfaces to be able to work out angles and ratios. So here what we've been given is a three-dimensional figure where all the outside edges that we have on this pyramid are all going to be the same length. And we need to figure out the angle of inclination, so the angle made with the base and this one of the triangular faces. We need to figure out that angle made from the base to the triangular face here, which we're going to call theta. Okay, so we have all the same lengths. Now, it doesn't matter how big this is, it's going to have the same angle, so we can just arbitrarily give it a length. So let's just call x equal to 2. Okay, now if we move into grade 12, we probably need to be using the x as a generalization and be able to do the algebra for this. But right now we can arbitrarily give it a length, and that makes it a little bit easier to work with. So what we need is then to be able to figure out two of these three lengths here. Okay, so this line here, right in the middle, okay, it's definitely shorter than the length of 2 here. We need to figure out this line here or this line here. Okay, so I'm just going to make this triangle in red in 2 dimensions. Okay. And there's my angle theta. There's my 90-degree in here. That's going to be the same triangle that I'm going to make right here. And there's one length I can get directly because I know that this is halfway from here to here along this edge length. So I'm just going to first of all just get that. So I've got half the information I need already just by inspecting this diagram. So then what I need to do from here is I need to figure out either this edge here or this height here. Okay, now this height here is going to be less than 2 and probably greater than 1, it looks like. So somewhere between 1 and 2. So how do we get that length? We can't make any assumptions that this is going to be the same as any edge length. Okay, that would be incorrect. Same with this face length here, along here. This cannot be the same as 2 because the edge length here is 2. So I'm going to use a different triangle here, and I'm just going to outline it in green. So I'm going to use the surface of that triangle here. That's an equilateral triangle. I'm going to use that surface. And I'm going to find this length I'm going to call y here. Okay, and I'm going to draw that triangle. So I need a picture here to work with. So here I have my triangle. Okay, this is my y. This is going to be 90 degrees here. So that's going to be my y. The bottom edge is 1. And this edge here is 2. And in fact, I know the angles in this. This is going to be a 30-60 triangle. Okay, but even if we don't know this is 30-60 triangle, there it is. I have 2 sides. This edge length here is 2. Okay, this bottom edge length is 1. And the vertical, this line here, which is 90 degrees to the base, that's my y. That's what I'm looking for. So I'm going to then use Pythagoras to find the y value. And that y value I'm going to put here. That's going to be the same as this length here. Okay, so in the red triangle, there it is. So I'm going to say y squared is equal to the long side squared minus the shorter side squared. So I get 4 minus 1 is 3. So y squared is equal to 3. Solving for y, I get plus minus square root 3. And I'm just going to use the root 3 because we just need a length. Okay, that's approximately 1.73. And again, I'm just going to keep it as an exact value because we really want to start using these exact values in math because it allows us to do more math on this. Okay, so this is approximately 1.73. Okay, that's about right. This is about 85% or so of the length of this edge here. Okay, so once I have the length of that side, now I have 2 sides of a right triangle. I have 2 sides of a right triangle here, which now allows me to solve for angle theta. And the 2 sides I have are going to be adjacent and hypotenuse. Well, going to my SOHCAHTOA, adjacent and hypotenuse is my cosine. So I'm going to set this up. Cosine of the angle that I'm looking for is going to be the adjacent over hypotenuse. I need to undo this because I want to solve for the angle. So once I have it, you can decide which function I'm going to use. I'm going to use the inverse for this one because I'm going from ratio to angle. 1 divided by square root 3 gives me an angle of 54.735, so I'm going to round that to 74 degrees. So there's my answer. Okay, and it involves being able to recognize that a 3D object, we have to use flat surfaces or 2D surfaces to be able to solve for these unknown angles and sides. If we're going to use trig, we need to use flat surfaces. So the surface I'm using is the one, if I slice right through the middle here, the red, and the other surface I'm going to use is this right triangle, which is going to be half of one of the faces.